Hey everyone, good morning and good afternoon. Happy New Year. It's January 6th, so 6 days into the new year, 2022. And we're trying out a couple of new things this year, in particular, this new channel of going live on LinkedIn. So thank you for joining us. We tried this late last year and seemed to go over pretty well. So I think we're going to keep trying this for a couple of weeks and see how the network likes it, what value we can bring to some of you folks here on LinkedIn. Again, my name is Manny Bernabe, and I focus on AI transformation for mid-sized companies, in particular industrials and manufacturers. We help companies think about how to leverage data, how to position themselves for an age of AI, how to use machine learning to infuse their products and to make their operations better. So that's me. And today I want to talk about a recent interview that Elon Musk had with Lex Friedman. It's a pretty lengthy interview, so we're not going to go through it all. But I do want to touch on some of the highlights that I saw, and we're gonna talk a little bit about some of the interesting points here. Again, 2.5 hour interview here. So I'll suggest you check it out. I'll add the link somewhere in the description. But in particular, what I'm interested in is in Tesla's self-driving vehicle. So let's listen to a little bit of this interview, and then I'm going to come in with a little bit more commentary on where I see this as being particularly interesting from someone that practices AI and machine learning. So let's listen to this, and you should be able to hear the sound, but let me know if you don't.
Ask sort of looking back the 6 years, looking out into the future, based on your current understanding, how hard do you think this full self?
Let me make sure you can hear the sound. Actually, I don't think you can hear the sound, so let me reset this. 1 second. Share screen, share system audio. Okay. That we should get the sound now. Let me know if you don't hear the sound. So let's
Driving problem. Well, let me ask sort of looking back the 6 years, looking out into the future, based on your current understanding, how hard do you think this full self-driving problem, when do you think Tesla will solve level 4 FSD?
I mean, it's looking quite likely that it will be next year.
And what does the solution look like? Is it the current pool of FSD beta candidates, they start getting greater and greater as they have been, degrees of autonomy, and then there's a certain level beyond which they can do their own, they can read a book?
Yeah, so I mean, you can see that anybody who's been following the full self-driving beta closely.
So let me just pause there. To solve self-driving next year, or this was recorded in December. So I'm assuming that they're going to roll out full self-driving capabilities in 2022. That's happening this year. And so I'll just say that to me, that is going to mark a major milestone in AI and machine learning. AI is one of those technologies that just changes the fundamental landscape. There's a term that economists use for this type of technology. It's called general purpose technologies. Examples of this are the internet, the PC, the personal computer, the electricity, the steam engine. These are once in a generation technologies that come along and just rewrite everything and upend the entire landscape and really just change quite a bit. And as I look in terms of AI and where it's going, and if I were writing the history books in 100 years and 150 years, the having full self-driving vehicles out in the world amongst actual drivers, I think that's going to be ranking very, very high in terms of milestones that we're going to look back on and we're going to say, wow, that marks an important point in AI and machine learning technology. So I want to provide that historical context. And if we think that AI is going to change our world in the way that we think it's going to change, in the way that I think it's going to change our world, then this is going to be a major milestone on that evolution. So this is going to be a big deal. I'm going to be watching for this in 2022. So we're going to be watching this. So it's just going to be a big deal. I also in part what makes this hard is if you watch my feed, I'll oftentimes be talking about launching AI in machine learning products in the world of bits versus the world of atoms. And so if you look at the internet age and what we've been able to do from an AI perspective in companies like Google, like Facebook, like Uber, that's all happening in the digital space of ones and zeros. Google, it's a website. You go there, and yes, they're crawling through a lot of data and sites on the web, but that's all digitized. It starts with digitization, and then you kind of go into machine learning from there. So that's one level of difficulty, and I think that's very, very hard, and it's difficult to do for sure. But the next level beyond that, in terms of difficultiness, is trying to do AI in the world of atoms in the physical world. It's when you don't start with digitization, when your data is being extracted from real world activities, and you're dealing with humans and other people, and you have this sort of somewhat chaotic, uncertain environment. It's just a whole different ball game when it comes to AI and machine learning. So while I think the work that's happening on the Google front, the Facebook front, is very interesting, I think the AI that's happening in companies like Tesla, that is going to mark a new, different type of capabilities for AI in machine learning. And in my view, it's an order of magnitudes much, much harder, because you're dealing with the physical world. You're dealing with people out that are going to do unpredictable things. You're going to be dealing with regulators. When you put AI out in the real world, you're going to get a lot of pushback from local politicians, from safety groups, in terms of what's happening. So the level of scrutiny that you're going to get is just going to be like pretty tough. And so that's why I think once we're able to see FSD, full self-driving capabilities out there with Tesla in this next year, I think it's probably going to get pushed back to 2023. I think it's still such a hard problem. I think it's just going to be such a big deal, and it's going to be interesting to watch in terms of how that gets rolled out, and also what is the decision to roll that out. And here we're going to talk a little bit, or Elon's going to talk a little bit more about how he's measuring where we are with FSD when it's sort of green light to let it out in the wild. So let's listen a little bit more here.
We'll see that the rate of disengagements has been dropping rapidly. So, like a disengagement be where the driver intervenes to prevent the car from doing something.
Right.
So remember, right now, FSD, there's a beta program out there that is allowing individuals to put in a location on a map. Like, you go on Google Maps, you put it in there, and then the car just automatically just drives itself there. But because it's beta, they have individuals with their hands on the steering wheel in case they need to intervene. And so it seems like they're tracking these interventions. So how often does a driver have to come in and stop the autopilot or the FSD from continuing the route? And that is a KPI. That's a key metric. And so you would assume that early on in your in the software, you're going to have a high level of interventions by the drivers over time as you update the software, as you get more information, then that should be going down, and that is going to be a really good indicator of how good your FSD capabilities are getting over time. And again, you expect that to be dropping off pretty rapidly as you get more data, as your architecture gets a little bit better. Let's listen to some more.
Dangerous potentially. So the interventions, per million miles has been dropping dramatically. At some point, and that trend looks like it happens next year, is the probability of an accident on FSD is less than that of the average human, and then significantly less than that of the average human. So
that explaining that to regulators and to people it's gonna be very tricky, because you have like proving something that's proving that something didn't happen. It's hard to do, and it's going to be hard for people to trust it. So I'm going to be interested in seeing how Tesla goes about doing this with regulators, with local politicians, local interest groups, how you make that case, because I think that's going to be a little bit tricky, and something that is going to involve more human psychology, persuasion than it is statistics, because in my mind, it's only a matter of time before autonomous driving gets much safer than humans. Like if you look at what humans are doing out on the road, distraction, fatigue, I mean, it's only a matter of time before that happens, and how you make that case is going to be interesting. And if you have you have like 1,000 trips that are all going well, one of them turns out to not go so well, and that gets you bad press. Like, how do people jump on that? How reactionary are people going to be? That is going to be interesting to see as well. So there's a technology part, but then there's also the human aspect part. And this is, again, why deploying AI in the physical world is really, really challenging, because you're not dealing with just ones and zeros anymore. Now you're dealing with human psychology, which is a little bit harder for your typical engineer types.
It certainly appears like we will get there next year. Then of course, then there's going to be a case of, okay, well, we now have to prove this to regulators and prove it to, and we want a standard that is not just equivalent to a human, but much better than the average human. I think it's going to be at least 2 or 3 times higher safety than a human. So
when it comes to technology, when it comes to AI, I think you need to be aiming for 10x improvement on whatever it is that you're doing, 5x to 10x improvement, because you have to take into consideration the fact that it's going to be expensive to deploy the new technology, that you're going to get skepticism, that you're going to get some, it's going to be harder to it's going to be some time before you fully prove out the full advantages of a new technology. So for that, when you're value modeling your AI and machine learning service, you want to be thinking about big magnitude changes. Like, it just can't be 20% better. It just can't be 40% better. It's got to be 3x, 5x, 10x better, if you're going, if you're in it for the long haul. So that's a good point.
2 or 3 times lower probability of injury than a human. Before we would actually say, like, okay, it's okay to go. It's not going to be equivalent. It's going to be much better.
So if you look, FSD 10.6 just came out recently. 10.7 is on the way. Maybe 11 is on the way somewhere in the future.
Yeah. We were hoping to get 11 out this year, but it's 11 actually has a whole bunch of fundamental rewrites on the neural net architecture, and some fundamental improvements in creating vector space. So
there is some fundamental leap that really deserves the 11. I mean, that's a pretty cool number.
Yeah. 11 will be a single stack for all, one stack to rule them all. But there are just some really fundamental neural net architecture changes that will allow for much more capability, but at first they're going to have issues. So like we have this working on like sort of alpha software, and it's good, but it's basically taking a whole bunch of C code and deleting a massive amount of C code and replacing it with a neural net. And Andre makes this point a lot, which is like neural nets are kind of eating software. Over time, there's like less and less conventional software, more and more neural net. Which is still software, but it's still comes out the lines of software. But
that's a very interesting point, and I think that is a theme that's come up quite a bit. If you look at someone like Mark Andreessen, he coined the phrase some time ago that software was eating the world. This was at the beginning of the internet boom, to signal how companies like Amazon, like Facebook, like Google were going to be dominating the economy moving forward. And you've seen that play out at Apple as well. These are primarily software companies, and now they're the most valuable companies in the world. A lot of that was being driven by software. And this was maybe like 4 years back. He rephrased that a little bit to say that AI is eating software. And the idea is that software allows you to encode a bunch of rules in a program that will run, but you still need a human to put together those rules and put together those heuristics. So a rule might be like, if you see this in the environment and these variables are in, let me bring this up. If you see X in the environment and these variables that are at these levels, then you should do this. And then if that happens, then do this. It's a bunch of rules-based kind of stuff. And that's helpful. That scales. And it's nice to have that consistency across many different types of environments, particularly for repetitive tasks that happen quite a bit. And that's where software really thrives, and you might have a lot of engineers doing that. Now, what we're finding with AI is that we're using AI and machine learning to not even have to go through that step, and we're using AI and machine learning to actually come up with the rules that should be used in place of the heuristics that are coming from humans. So now, like we were in a world where software was eating the world, now it's going to be around AI and neural nets eating software to actually come up with the rules that are going in the software. It's a very sort of nuanced and interesting kind of perspective, but I think it's an important one, and it kind of speaks to why engineers need to be thinking about how to streamline their workflow with machine learning and AI and those types of technologies. So that's a very interesting point. Let's continue listening to this. This is good. And feel free to jump into the chat. What do you guys think? Have you seen this interview? Is what's resonating for you? Any other areas in this interview that stood out for you? I'm just covering the AI parts, but there's SpaceX, Mars, other things that are coming on here. But feel free to jump in the chat and let me know what you've been following.
And less, heuristics, basically. If you're more matrix-based stuff and less heuristics-based stuff.
And again, heuristic is just a fancy word for a rule. So if this, then do this. If while doing this, just basic rules that you would find in a simple rules-based type of setup. So that's just another word for a rule.
Like one of the big changes will be like right now the neural nets will deliver a giant bag of points to the C++ or C and C++ code.
Yeah.
We call it the giant bag of points.
Yeah.
And it's like, so you got a pixel and something associated with that pixel. Like this pixel is probably car. This pixel is probably lane line. Then you've got to assemble this giant bag of points in the C code and turn it into vectors. And it does a pretty good job of it, but we need another layer of neural nets on top of that to take the giant bag of points and distill that down to vector space in the neural net part of the software as opposed to the heuristics part of the software. This is a big improvement.
Neural nets all the way down is what you want.
It's not even all neural nets, but this will be just this is a game changer to not have the bag of points, the giant bag of points that has to be assembled with many lines of C++, and have a neural net just assemble those into vectors. So the neural net is outputting much less data. It's outputting this is a lane line, this is a curve, this is drivable space, this is a car, this is a pedestrian or cyclist or something like that. It's outputting it's really outputting proper vectors to the C++ control code as opposed to the sort of constructing the vectors in C. Which we've done, I think, quite a good job of, but
all right, it's getting a little wonky. But I guess what I would say is many people underappreciate how much work goes into data processing for an AI service. In fact, I would say that, if you look at your standard AI product or service, 80% of it has nothing to do with the actual data science model or the object that is making prediction. 80% of it tends to be get the data, collect it, process it, clean it, filter it, and then feed it into the model. That takes up a lot of time in your AI service product development. And this is why he spends a lot of time talking about this, because it is a major pain point. Now, from my understanding, for FSD 11, which is supposed to be the one that solves full self-driving capabilities, they're going to do a refactoring of the architecture. They're going to be thinking about how to better process this data that's coming from the different sensors and the different cameras on the cars. And so there's just going to be a lot of work that has to do. And yes, that's probably going to leave Tesla with better capabilities. But that's a lot of work. And it's a lot of refactoring. And when you refactor things, bugs come up, new things come up, and you have to do retraining on a lot of the new data. And so does that jive with, historically what you've seen? So that's going to be interesting to see. So that is FSD. I think there's just one, Teslabot. I wanted to talk about Teslabot. So let's, I encourage you again, check out this interview. Let's talk about Teslabot. So Teslabot was I think it was summer of last year. Tesla had an AI show where they talked about their architecture when it comes to autonomous driving, and then they also previewed a Teslabot, which was going to be taking some of their AI core competency and putting it in a robot type of object. To do different kind of things. And so let's hear what Elon has to say about that.
Yeah. So you've presented Teslabot as primarily useful in the factory. First of all, I think humanoid robots are incredible. From a fan of robotics, I think the elegance of movement that humanoid robots, the bipedal robots show are just so cool. So it's really interesting that you're working on this and also talking about applying the same kind of all the ideas of some of which we've talked about with data engine, all the things that we're talking about with Tesla Autopilot, just transferring that over to just yet another robotics problem. I have to ask, since I care about human-robot interaction, so the human side of that. So you've talked about mostly in the factory. do you see it also? Do you see part of this problem that Teslabot has to solve is interacting with humans and potentially having a place like in the home? So interacting, not just not replacing labor, but also like, I don't know, being a friend or an assistant.
I think the possibilities are endless. Yeah, I mean, it's obviously like it's not quite in Tesla's primary mission direction of accelerating sustainable energy, but it is an extremely useful thing.
Let me just pause there and say that AI is why I think it's so critical for companies to start working on their analytics, their machine learning, and AI muscle, because AI is one of those core competencies that grows over time, and it extends across the organization and across different business units. And it's one of those capabilities that you seemingly unlock, and then you're like, wow, like, yes, I was able to apply it in this use case for this particular business unit, but then I'm able to apply it here as well for this other business unit and for this new product. And it's one of those things that just kind of tends to grow over time. And what you'll find is you can extend this technology to places that you otherwise may not have thought you could extend it to. So in this case, what Tesla is doing is they're using the AI capabilities that they're developing for autonomous driving, the Tesla cars, and they're extending that to robotics and this Teslabot, and that seems totally feasible to me. The same lidar system that you have on cars, the same ability to take photons and images and video streams and put that into an object that has to move in the real world, that has to do that with low latency, with low jitter, and has to react quickly and has to be mindful of certain things. Like, that is totally plausible for me to think that you can do that. If you can do that for an autonomous vehicle, you can probably do that for a robot. There's going to be some retraining that has to happen. There has to be some sort of rebuild, but that's a pretty straightforward expansion in my mind. And I would say that's kind of that's part of the reason why you want to be investing in this technology. You want to get that skill set up. You want to start developing that IP for you to be able to do that in-house and extend it to other parts of your business. All right, so I think we've gone over our allotted time for today. Let me know if you have any questions. Let me know if you have any comments. I'll check it in on the live stream and see if anybody has any comments that they want to chime in. So, but I'd be curious to know what you guys think about this. If you find this interesting, if you have anything you want to call out, if you've even caught the interview, I would say check that out. We're gonna try to go live twice a week. Try it out, Tuesdays and Thursdays at 10 o'clock. And so we'll see how that works out. Next Thursday, I'm happy to announce that we have a guest that is going to be joining us. We have Luke Small, who is the founder of Chakra, a company that helps mid-size OEMs with digital transformation. And so he's got a great background in terms of having been at GE and head up some of the professional services there at GE during their ramp up of digital capabilities. And so we're going to be having them live on next Thursday so make sure that you tune into that and you join us. He's going to be joining us for the second half of the show, so around 10:30 or so. But I'll make an announcement and make sure that's out there. Let me know if you have any questions. Let me know if you find anything else that's interesting out there. And until next week, I hope you have yourself a really great weekend, and we'll talk to you soon. Goodbye.